Hello everyone, welcome to this video whereby we want to see how we can derive the equation of linear uniform motion. So we are going to look at this equation. We want to see how we can derive V is equal to U plus AT, S is equal to UT plus half AT squared, V squared is equal to U squared plus 2AS. In this case, V stands for the final velocity, U initial velocity, T time taken, A acceleration, and S distance taken or distance covered after time T. So we are going to assume that our body starts at velocity U, and at time T here, our body will have covered velocity V. So we begin by defining acceleration. Acceleration is defined as the rate of change. So this is defined as the rate of change of velocity, with change in time. So in our case, velocity changes from u to v. So it will be v minus u divided by time t. So which we can write that a is equal to v minus u divided by time t. So you can multiply by t in both signs to obtain AT is equal to V minus U. We can add U in both sides. So plus U this side and this other side plus U. This implies that our V, U plus U will give us 0, will be equal to U plus AT. So we have done the first one. So the second one, to do the second one, what we are going to do now, we are going to obtain the area. The area under this graph, is equivalent to the distance covered. So we get area under the graph. Area under the graph is equal to distance S. Area under the graph is equal to distance S. So the area under the graph, as we can see this diagram here, it is a trapezium. This diagram here, it is a trapezium. So the area of a trapezium, so S will be given by half height multiplied by A plus B. In our case here, our height is T, our A is U, and our B is V. So this is the same as half height, T into bracket U plus V. So this equation here, we can call this number 1. We call that number 1. So S is equal to T over 2 into bracket U plus V. Now remember our equation which you want to derive, it is this one. S is equal to UT plus half AT squared. So our equation here has no V. So what we are going to do now, we are going to substitute V in this equation. So our S will be equal to T over 2 into bracket U plus, instead of V, we are going to write this one. We are going to write U plus AT. You can this is T over 2 into bracket 2U plus AT. What I have done, I have added U plus U, it will give you U 2U. It's going to give you 2U. To do, we are going to remove the bracket. So S will be equal to 2 So it will be equal to 2 ut divided by 2, this 2, plus t at squared over 2. So s is equal to u2 ut, 2 and 2 will cancel, plus half at squared. So we have proven the second bit. Now then, from there now we are going to say from 1, that is v is equal to u plus at. Then it means that v minus u is equal to at. Our t is equal to v minus u over a. So what you are going to do now in s is equal to u multiplied by t, which is equal to u plus v over 2. So instead of t, we write this one. We write v minus u over a. So from here, we are going to use this idea a plus b into bracket this identity a minus b. So the result here is a squared minus b squared. In our case, we have u plus v into bracket v minus u. The result here will give us v squared minus u squared. So that is the idea we are going to employ there. So using that idea, we are going to get now our s. S is equal to, here, we are going to have v squared minus u squared divided by denominator. It is 2 times a, 2 times a, which is 2a. V squared minus u is equal to 2as. We can take u squared the other side. So v squared is equal to u squared plus 2as. Hence, we have shown that v is equal to u plus at. S is equal to ut plus half at squared, and v squared is equal to u squared plus 2as. So when you are working, you substitute the appropriate, you are going to substitute the appropriate values depending on what you are given. Bye. Thanks so much for watching this video tutorial. Kindly you can subscribe so that you don't miss any single video which I upload.